I think that it is about time for me to add support for CAN 2. So I have both CAN interfaces, CAN 1 and CAN 2, connected now with a loopback wire, so that I can test the CAN buses, make sure that all that everything works in terms of both the low-level driver and also later the CAN open driver. And then once I get everything working on the single board, I can then connect the two boards together and move on from there. But before any of that can be done, I need to add support for the second CAN interface. And to do that, I need to add interrupt handlers for CAN 2, because the way I have it designed right now, I only have CAN 1. So let's see, we have CAN 1, we have 4 interrupt handlers. Let's see here. So these ones, the interrupt controller setup is all handled properly. And even the interface is enabled. The only thing that's missing right now, I think, is and the clock is enabled there for CAN 2. The only thing it's missing is the interrupt handlers that actually get called when messages arrive on CAN 2. So I will just copy this, and instead of going with CAN 1, I will do it with CAN 2. Let's see, process message ESR. Yeah, why am I even doing that? So this is a bit of an artifact from the way the code worked before. So this is not needed. Let's see. And this is actually called from several places. Like this. So if let's see, if interface 0, so if CAN 1 has been initialized, then we call this function. Oh, actually, yeah, we already have self there, and if not self, then we have a bug. So no need to do anything else. And this will go to CAN 2. And actually, all of this can move into the function up there. I'll just check first process message. I think it's used in a different interrupt as well. Nope. So that's just the two places where it's used, so I can basically just move this to the function here. Let's see. Process message. And this converts the message from the internal STM32 format to a more generic format, and then forwards it to the queue. And that goes away. Length, thread queue, and this goes to self. Right. And instead of CAN 1 here, I will use the pointer to the CAN interface, which is passed from the device tree. So self HW. And all of them also will have to be correct pointers. So this seems to be alright. Now CAN 0 here, or CAN 1 needs to be also modified. So let's see here. What is the difference here? Right. So there's also I need to check the right register as well. So if I have FMP1, I will be checking on RX1. So I need to make sure that I'm using the right queue. So now I should be, let's see, and also the counter. Let's see. So this was actually probably better to have in the interrupt. Like, now that I think about it, no. I didn't notice that it had different flags there. So yeah, much better to have it like this. And then RX1 there as well. Let's see. This goes away. And RX1 over there. Okay, that's better. And then thread wake. Let's see. This will reschedule the threads upon exit from the interrupt routine in case anything has been pushed into the queue. So it's good to do that. So I have RX0, RX1, and then TX is here. And the state. The errors. So just gonna add similar vectors, similar interrupt handlers for CAN2. And reuse this code. and this one will be rx1. Actually, yes. Let's call this rx0. xr self wake, and then can1 rx1. Gonna be very similar. And can2 rx1, and then I just need to add rx1 method here. This will use the flags and FIFO for second receive queue. Okay. Let's make this inline. If it will even inline. I don't think. Maybe I could put it like attribute force inline. Is that even an attribute? Is that a valid attribute, force inline? I know there is an attribute for forcing inlining, but I'm not sure what it's called. Always inline. I see. Always inline. Okay. And then the TX handler for, I could actually use this probably. This is pretty generic. So receive from TX queue, yeah. So this can be moved into a separate function. And also for can2, I need to use the second one, the second interface. Okay, can tx ESR, and then let's add also the wake. And wake is going to be, if we can receive anything from the queue, then we do wake equals 1. or yeah, actually just like this. So can1tx and then can2tx here. So the result should be now, when I have the CAN buses connected, when I run my CAN test, where I just send out a single CAN message, it shouldn't, the interface shouldn't be retrying the CAN message all the time. It should get acknowledged, and then the interface should be quiet. Making this driver more generic. So the same code works for both can1 and can2. Okay. SC handler will do this. The same thing, wake. Except that this one doesn't need wake, because it just clears the flags. I could have wake anyway there. So the reason I have this interrupt routine is to record the number of errors, which can be helpful when debugging CAN problems. For example, if there is some disturbances on the bus and sometimes messages don't get transmitted properly, the CAN interface will actually log that, and it will also call the interrupt when the flag is set, and then I can increase the appropriate counter. Okay, so is there any other place where I have can1 here, besides the names of the interrupts? Nope. And this code is not necessary. So this should make the can2 work. I don't know. I'm gonna have to check. Return type, of course, void. Could I forget that? Oh, and here also. So this is not correct. Do I have a duplicate of this? Huh. Okay, anyway, this is not correct, so this will have to be self. 1 is index 0 and can2 is index 1. Okay, seems good. Always inline function might not be inlineable. Yeah. Okay. So because the function is too big, GCC is not going to inline it. Even though I told GCC to always inline. Screw that. I'm going to remove that. And D2V. That worked. Let's see. Another one there. Okay, this seems to work. Okay, and it's actually running, so at least it doesn't crash. Now I'm gonna bring out my scope, and I will try to send a message on the CAN bus. So in the default state, without any messages being sent, I have CAN H here and see CAN L there. So they're both like at how much? 2.5 volts. Yeah, a little bit, or actually, yeah, actually it's 2.5 volts. So both are at 2.5 volts. So when the message is going to be sent, CAN L will go down and CAN H will go up to 5 volts. So let's see. No, it just crashed. Something crashed. Okay, so the LED is not blinking anymore, so it crashed. Time to fire up the debugger here. Let's see where it crashed. So I'm going to fire up the STUtil without resetting the board. So N flag specifies that I don't want to reset the board. And I'm in the SC handler. Is the SC handler being called repeatedly? Let's see. If I continue. Okay, so it seems that SC handler is being called repeatedly, and some flag is not being reset. Yeah. So it's always in the SC handler. So next thing I want to check is what exactly is the error that's happening here. Right, and what was it? Was it CAN 1 or CAN 2? CAN 2, okay. So, CAN 2 SC handler. Oh, well, that's not surprising. This one should be using the second index. So, reflash, maybe it works better now. Yeah, I have to stop STUtil. STUtil is not running. And now I can reflash. So, maybe this works better. FB CAN. So, I'm going to put the scope to the, let's see, can I do this? Maybe I can do it like this. Maybe it wouldn't work. I'll do like this. So because I can see my screen through the terminal, so I can see the scope as well. I'm just going to put it here. Now it's there, and then just run this, and it's not really working. It's not receiving anything. And to be honest, I think the signal is pretty weird. This is a bit strange waveform. It's like it's not really a square wave. So what is going on? So why is can H going below? So can L. So can H and can L are what? Reversed maybe on my connector. Let's see here. So this is supposed to be. Let's see if we get anything on the TX and RX. Okay, so this is on. I always have to check because I don't know which one is TX and which one is RX, just to make sure. So I have to check over here, here. So right, so that's TX. So I'm gonna be. Oh, damn it! Maybe I was transmitting on both of them. So I remember I have that code that transmits on both. But anyway, it should work anyway because any messages that go out on one interface should be acknowledged on the other interface. Let's see. So this is TX on CAN 0, and this is RX on CAN 0. TX, RX. And CAN 1, TX, and RX. Okay. Where's the period of this? Am I right to say that this is 240, 360 nanoseconds? Or is that wrong? Which doesn't seem right anyway. Oh, okay. So the 120 nanoseconds, that's wrong. It's actually 10 microseconds. So the distance between let's see. Maybe I can move it. Can I move it? Position. Yeah. So the distance, the period of this wave would then be 25 microseconds, which seems a bit odd. It would depend what the wave actually contains here. So I'm just gonna check whether this. Also, I want to just send on one interface, not on both. So a little CAN test here. I'll be sending it on CAN 1 only. Now, CAN 1, is that TX? No? Huh. Okay. Oh, yeah, right. I have to restart this, of course. Let's see. Like this. So, now I should be seeing something. So, CAN 1. Maybe I should be calling it CAN 1 and CAN 2, not CAN 0 and CAN 1. So CAN 2 TX is not active, and Rx is active. So there's data coming in from the transceiver, but it is not. Let's see. It is somehow not getting into the chip. And I'm also kind of curious what kind of data is that? Is that the sort of the transceiver or the CAN interface trying to establish communication, or is it something else? Because usually when a message is sent on the CAN interface, it actually the CAN interface will retry the message, but it should be coming out more than just the same pulse all the time. It should be a more pretty waveform. Time to read the chat, the live chat on YouTube. Damien is the only one writing in the chat. Hello, Damien. Anybody can learn to be a good programmer. Yeah, I was thinking about pulse view actually, but I will do a few checks first and I'll fire up pulse view. I wish pulse view had a better waveform view. Like the user interface is not really, it's not really to my liking. I like this user interface a lot, but in pulse view it gets like it's a small signal and it's like, yeah, it's not the same type of real-time signal like here. This is nice. But one thing I want to check now. So I want to check actually a few things I'm going to check. First of all, I'm going to check the connections, and then I'm going to check how I'm configuring the baud rate, because this seems to be like maybe there is something wrong with the baud rate. So the CAN interface is over here somewhere. Where is the CAN interface? Where did I put the CAN interface? There. So this is the CAN interfaces, and it's TX, RX. Please don't be connected wrong. CAN1 RX, TX, that's right. And then CAN2. Where's CAN2 connected? The moment of truth. CAN2 TX. Wait. This text is so long though. Damn! No way. Wait, is that correct? Am I? Oh, yeah. It was actually correct, because that one is TX. CAN2 TX. CAN2 TX. That's there. And that one is RX. So this should be correct. So connections should be working. Now, another thing also, I'm going to check that the signal is actually coming to the pin of the MCU. So I'm going to check on CAN2 RX, and I'm going to see if this pin is actually receiving the signal. That was easy enough. The pin is on the side, so it's easy to check. And what signal is coming out on the actual pin? Is there anything coming out on the pin? Yeah, it's coming in. So it's something else that's wrong here. I kind of suspect that it could have something to do with my setup of the clocks, but I have to check a few more things as well. So starting with the device tree. Let's have a look at the device tree. We have CAN1. So this is CAN1, prescaler 7, CAN2. Okay, so starting with the configuration of the pins, I'm going to make sure that the settings for the pins are correct. Should they be push-pull or should they be open-drain? I think they should be push-pull. Or maybe it doesn't matter because it's alternative function. I think that instead of writing this HAL library and doing the same mistakes that they did with the other library, or maybe I wouldn't say mistakes, but it's like the standard library, the standard peripheral library, it had a good enough good enough structure. Like it's supposed to be simple. It's supposed to be just functions that write to the registers and make things easily readable. But doing anything more than that is kind of out of the scope of that code. So I think it kind of feels like a waste of time to have a different HAL library. But anyway, that's not my problem. So does it say anything here? So this person is just asking about the configuration. I want to see some answer. Configuration of a Rex pin. Maybe the Rex pin needs to be configured in some special way. If anything, I could actually check some repo on GitHub, see how they do it. So no pull probably doesn't matter. Okay, so the only thing here is the use of no pull. Turn off the push up, pull down resistors. Pull up, pull down. Let's see. Must be configured AFPP. Yeah, so this is exactly like I'm doing it here. So that should be working. Except I'm going to be setting this to GPIO-PUPD, no pull. I love this way of configuring GPIOs. So the way this works is that I have a few headers that are specifically designed for the device tree. I've described it in another video. But the way this works is that in the headers, I can write expressions like the typical C preprocessor expressions. So I can define these flags to be some actual values, but I then use the definitions here in the device tree, and I can even use expressions. So for example, this is an OR expression because it ORs different options for a bit. And then when the device tree is compiled, it's just running through the C preprocessor first, and then through the device tree compiler. So when the device tree compiler just sees numbers in place of these definitions. But for the person editing the device tree, it's very useful to have definitions like this, instead of just having like hex numbers. 0x, like 40, whatever. And that's supposed to refer to CAN1. Yeah. Anyway, so what else could be the problem with CAN bus here? What else? I'm going to print out the frequencies I'm using. I'm pretty sure I'm using the 49 megahertz. Let's see, where is the clock? Okay. So unfortunately, I cannot print out anything from the driver that is responsible for the CPU, because nothing else is initialized. And this one needs to be initialized first. So I can't do any prints until serial is initialized, and then cons. Well, actually, just the serial. Serial is enough for printing things out. That's why serial is the second node in the device tree. What I could do actually is just print out the information here. And the problem is that I don't have access to STM32 stuff here, which is a good thing. So I have to print it out somewhere else. I have to print it out. It's like I don't want to add any interface methods for just printing out the clock frequencies. I want to do it somewhere in some driver, in some STM32 driver. I'm going to just print it here in the CAN driver. CAN driver initialization. So before CAN is ready, you can do like this. RCC get clock freaks. Clocks. P clock 2, and there's is there H clock? I think it's called H clock. This is clock frequency clocks. And I'm a bit uncertain whether this method actually, like when getting the clocks, does it actually return correct values if RCC is maybe misconfigured somehow? I wonder how I could check whether the clock. I could actually, I could configure some timer to output some like pulse on. I do have the PWM though, but anyway, I'll check this first. P clock 1 frequency clocks. The PWM seems to work fine though. So the only thing that's keeping me wondering a little bit about the clocks is that this chip is supposed to be able to run at 100 megahertz, but and that's actually 100 megahertz for the main clock, but it doesn't actually do that. It seems to be running at 50 megahertz. Well, once this prints out the clocks, we'll see what it's actually reporting that it's running on. So this is running on. So 98 sys clock and H clock 49. And I think that H clock is actually, let's see, why is it? Maybe the line is too long. Maybe that line gets short. And if I set it to 100, so that like sys clock is 100, it doesn't actually even boot. Let's try that. So we have HEC value 8 megahertz, and then we divide. So how did this work now? So we have 8 megahertz times what? Like times one of these. H clock is okay. So HEC value divided by PLLM times PLLN. So PLLN is 196. So what if I make this 200 then? So is it gonna boot? It did boot. Cool. Okay. Maybe it just doesn't work if I set the clock higher. But the H clock, I think I'm pretty sure that H clock should be able to go to 100 megahertz as well. I'm going to bring up the datasheet and check. Not this one. Where's my datasheet? Could be this one. Advanced ARM microcontroller. How many pages? Yeah. 1700 pages. That sounds like a STM32 datasheet. H clock. What could I search for to kind of get the maximum values, like maximum frequency? Maybe 100 megahertz. Maybe that will return something. No? I mean, even in the definitions, there is when setting the speed of the GPI, you can set it to 100 megahertz. So AHB clock must be able to go to 100 megahertz. Let's see. Maybe I should actually try that again, because let's see. So where is this H clock divider? If I set this to 1, so H clock is sys clock. Maybe that's +1. Let's see. How do we get it if we do it like that? That's very weird. It's just working now, so I don't know. I had this problem before, and it's in a video somewhere where I was trying to set the settings to make it run at 100 megahertz, and it just wouldn't do it. But now it's working fine. Maybe I fixed something along the way. So what about the CAN bus now? What does the CAN bus look like? Oh, interesting. Let's see. CAN. Every single time when I forget to run that command, I'm like, oh, CAN bus is working. But CAN bus is not working. CAN bus is actually behaving exactly the same way. But why? Wait a minute. So interesting. So it actually seems to have arrived somehow. So let's try this again. Always on top. Let the CAN. I'm going to connect this to CAN bus. Although, of course, I have to revise the baud rate settings now because I changed the frequency of the clock. And is this not running? So nothing on the CAN bus. The CAN bus is stuck. So I have to revise the settings for baud rate. So now that H clock is 100 megahertz, it's going to be, let's see, prescaler could be, I think I should be able to set it to 10. There is a limit to the maximum number for the prescaler. Where's the CAN bus? CAN bus. And also for the other settings as well, there are limits. Like, for example, I think one of them cannot go above 4. So I have to check whether I'm within the limits. Actually, that should be checked in the driver. I should be checking that in the driver. Where is CAN bus? CAN bus, CAN bus. VXCAN. No. CAN. Where is this section about the CAN interface? And this list is so long. Maybe I can collapse all the sections. How do you collapse all the sections here? GPIO system. CMI. There. So let's see here. This CAN peripheral is a lot more complicated than what I've implemented support for. It has so many functions. I'm currently just running it in, I'm not even using the filters. I kind of accept everything on the bus and then process the messages as they come in. So bit timing, synchronization, let's see, SJW is between 1 and 4, and this has to be between 1 and 16 and 1 and 8. So it should be possible to we run it at 10, get 10 megahertz. I set the prescaler. And also, now I have all the clocks on the same frequency now, apparently. It's like 100 megahertz everywhere. Where's the prescaler? I want to just check how big the register is for prescaler to see the range of values that it can accept. Bit timing register. Okay. Okay, so let's print out, let's see, so if I use prescaler of 100, which I should be able to use, so this is up to 512, then it would be, the time quanta would be the time it takes for the period of the 100 megahertz clock plus 1. Or, oh no, actually, yeah, so if if the prescaler is 0, then obviously it's kind of like not dividing anything. And if it's 1, then we divide the clock by 2. Yeah, so that makes sense. That makes sense. So in the initialization, I should be subtracting 1. Or maybe I should actually be running this at 10. Let's see. This is unit 16 also. BS1 is between 1 and much. Where's the bit timing? Bit timing, there. Line 16. And 2 is up to 8. And then prescaler. And then I will actually just, yeah, we'll have -1 there. And the quantas, I'll just keep them the way they are right now. Okay. So then I have 10 in total, which means I can keep that in. I can make that 2 and 4, 4. So the sum is equal to 10. And then nominal bit time becomes the sum of all of the time quantas. So if we divide the clock such that, so let's see, nominal bit time is TQ, BS1, BS2. So let's see, what are we going to be getting here? So the bit time will be, let's see, 1 divided by 10, that would be the TP clock, 100, times 10, that would be the time quanta, and then that will be TQ plus, let's see, so is this has nothing to do with the SJW, I guess. This is just one time quanta. And then there is BS1 and BS2. So BS1 would be times so it'll be 5, 10, so plus 10, yeah, so basically times 10, right? Yeah, and that should provide 1 microsecond. So this should be 1 megabit per second, if the calculations are correct and if my setup is correct. Congratulations. Yeah, I like Louis Rossman. I think Louis is doing a very good job repairing PCBs. And the first time I saw a video that he did, I was like instantly, yeah, this is a good channel. I'm subscribing right away. CAN 2 missing. What? So did I do this wrong? Oh, okay, so I have been subtracting 1 because my idea was that that I would actually use the values defined here. Or wait, no, my idea was that I would be using values that make sense when adding them up. So like TQ1 is actually defined as 0. So if I enter a value of 1, I get 0. Okay. So it makes sense to just move this here. That's better. I don't really need this anymore. I could leave it there for now. So, CAN, FB, CAN. Is it sending anything? It's behaving in the same retarded way as it did before. It's like okay. TX, RX, TX, RX. So this is on CAN 2. There is nothing on transmission, but there is reception. This is the reception, and I think, let's see. Okay, it does seem to stretch that pulse a little bit on the reception. I don't know why. Why does it do it? Maybe it's actually. Oh, I just shorted the CAN lines. So now it stopped sending. There's something I want to check actually. On my CAN transceiver, do I have any silence pin? Yeah. Standby shouldn't be. Yeah, it should be to ground. So the CAN transceiver should be transmitting. So, could it be something else? Maybe I forgot something. It looks like maybe the receiving side is not actually acknowledging the start of transmission somehow. CAN 1, CAN 2. Do I ever enable the CAN device? CAN init. Yeah. Or maybe it's not necessary. CAN init. Call CAN. Yeah, actually, I do that already. So that's fine. I'm gonna set a breakpoint on the RX 0, maybe RX 1 as well. CAN 2 as well. Actually, it's CAN 2 that's more interesting. So maybe I need to restart actually, because I shorted the CAN lines. And, let's probably in error state now. Reboot didn't work. Oh, of course it didn't work because by default GDB breaks at reset handler. So should I be able to get the RX interrupt running now? Nope. It's not receiving. Why is it not receiving? Oh, of course. Haha. So funny. I forgot to set prescaler on cam 2. Maybe this will work better. Let's see. Okay, time to check this. And did we get anything? So I don't have GDB running anymore, but no, it's the same issue. So bring on the scope, and we have the CAN 2 TX and CAN 1 RX. Yep, and CAN 1 TX not active. So things are coming back in, but they are not being received properly. Okay, I'll try this. What about a lower baud rate? 125, 50, 16, 13, 13. Oh, okay. So 13.2. So 1008. It has to be 7009 there. So the register has the precise value that is specified in this table. And it seems to be working. Maybe it's just 1 megabit that's not working. It seems to be, let's see. So, of course I cannot tell that it's actually working until I've seen the waveform. I've seen the data being transmitted. I need to make sure that my probe is this maybe. I'm gonna just hold the probe with one hand and just press enter here with the other hand. So FB can probe going to can H, or can L actually, and no, nothing, nothing, really, nothing coming out. What is going on in this canvas? I just need to make sure that my probe is sitting tight on the connector. Like that. Okay. Oh, there we go. Great. No, nothing coming out. No, it's not sending anything at all. Peak clock 1 and 2. Let's see, I should be actually able to run this chip faster. But that shouldn't matter. This should be. This is the same datasheet as this one. It was the other chip on a different board that didn't run at 100 megahertz. This one runs just fine at 100 megahertz. So let's see. I want to check the maximum frequencies of the clocks. So this table seems to go just up to 84 megahertz, and I have the chip now configured at 100 megahertz. So according to this, the prescaler can be set to 1. So AHB can be equal to sysclock 180 megahertz, and APB as well. So APB 1 and 2. So they should be able to run at 180 megahertz. not, it's the 360. Probably won't matter, but I just want to make sure that it runs at 180. So M is correct. Around 180 and 90 for the peak clocks. At 160. I don't think the clocks are the issue here, at least not the system clocks. It's something else. Oh, interesting. This looks a bit better. This looks more like CAN. So maybe I was wrong. Maybe it is the clocks. Let's see. Okay, so there is some data being sent there, but it's kind of not coming out right. It's very long slope on the signal. Well, yeah, this should still work though. This is I've seen much worse signal on the canvas. is the received signal. So the message is being transmitted better now. This looks like a CAN signal, but nothing is being received yet. Did I actually update this? No, I didn't. 13.2. Okay, so back on this thing. Why is this not working? No, did I just put 10? Damn it. I'm getting tired. Okay, so having the prescaler at 50, maybe there is some maximum clock that the CAN peripheral can support, because having it at 50 does result in a signal being sent. So what if I set this to 50 as well? The receiving end. Look at that! It's actually working! Damn it. Okay, so now it's working, and it's the message is being acknowledged. I haven't read the message out of the buffer on the receiving side, but I'm pretty sure it's going to work. I'm gonna investigate why having prescaler at a value at a frequency higher than, let's see, what is it now? So it's at 50, and we're running at 80 megahertz on peak clock. So we divide then 80 by 50. This is like 1.6 megahertz. Why can I not run it faster? Why is it not working if I set the CAN peripheral clock faster? Maybe there is some limit somewhere. But at least this is working now. So that's great.